We're in China, Qingdao, in the QMW yard. This is the Woodside Scarborough project. It's a structure that's going to be within the Scarborough field, which is a gas field. So the topside will be a floating production unit, circa 400k from the shore, in 900 meters depth of water.
The benefits to modular construction for the client in this particular case is that you can construct the topside and the semi-submersible hull in parallel. So you can essentially halve the construction schedule.
With the methodology that Mammoet provided, we enable them to use little cranes, i.e. less lifting heights, heavier loads, speed, efficiency, and also safety due to working at lower heights.
And then it can go offshore for installation within a matter of days. If you think about it, if you're constructing it at height, you need more access. You need more access for people, you need more access for equipment, and that means more scaffolding, it means more stairs, it means bigger access platforms and bigger cranes. So when we build as low as possible to the ground, we have a more safer environment, a more productive environment, and ultimately spending more time on value-added tasks, on having time on tools and less time climbing stairs.
Scarborough topside will dehydrate gas and compress it. It will allow gas to come circa 400 kilometres back to Australia and ultimately be in your kitchen to cook your next meal.
This is the QMW yard. Here behind me, they are building the Scarborough topside. Topside is a really big factory which will be located on sea. The factory consists out of a production unit, but also living quarters that allows full operation offshore. There are, of course, multiple methods to install topsides offshore. This method is just to pick up the topside, bring the DSF underneath, bring both parts on the barge, where the final installation can be done.
Post-loadout, we will then go offshore. We will carry out the float over. And the float over is the integration of the topside with the substructure. In this case, the Scarborough FPU, floated production unit, circa 400k from the shore in 900 meters depth of water. Mammoet can be involved from the very early stages. This project started 8 years ago when we first got engaged and we started to develop our methodologies with the client.
It's very technical work, it's very precise work, and your margin for error is very, very small. So it's very much advised to have your technical experts involved and integrated with your preparation and your planning teams as early as possible. Together we came up with the concept of actually integrating the jacking starter beam in the topside.
Our starter beam is the interface between our jacking system and the topside of the client. Normally without an integrated starter beam, you have support to the client, with our starter beam on top, which needs more height. And now we have integrated starter beams which lower the fabrication height.
And that allowed us to build substantially lower to the grade than was initially anticipated. So the reason that we weigh the topside structure is not only so that we have an exact weight, but it's also so that we have an exact center of gravity. It's very technical work. Your margin for error is very, very small, so you really need to be exact.
We can tell the client the weight and location of the COG within 0.5%. That data is required to have a safe operation offshore.
So when we have the full weight and we have the center of gravity, that's very critical for the ballasting operations during the loadout and the float over. That ensures that the barge and thus the topside remain level at all times through the operations.
The weighing cells are integrated in special design kits for the MegaJack, which allows us to perform the weighing using the MegaJack system. In front of the topside there is located the DSF. It's called the deck support frame, which is used to integrate the topside together on sea in the hull. Yeah, the DSF is built in front of the topside to allow easy access during the fabrication time. Because both DSF and topside are built on a lower level, they can be fabricated in the same time, which saves the clients, of course, some time.
We're assembling the MegaJack system underneath the module, making it ready for jack-up. The MegaJack is the heaviest jacking system within the Mammoet fleet, used to jack up large modules. It's completely engineered within our R&D department.
The MegaJack is already used for more than 10 years within Mammoet, with a world record of 42,000 tons.
The MegaJack system works with the principle of stacking jacking beams on top of each other. The higher you want to go, the more beams you put in between.
Once all the parts of the MegaJack are installed, we connect the hydraulics and then we perform the function test, and then we are ready for a safe operation. As you can see, we have already jacked up one layer, which means we have already done the initial pickup. The initial pickup is a very exciting moment because at that moment we see the weight of the topside and the loads on each tower.
One of the coolest new features of this system is a self-learning calibration function. It moves up a couple of times and it learns how to function the best. The results were astonishing. We could reach synchronization accuracy that we've never done in the past.
Now for the loadout, we are supplying the strandjack system. There's a breakout system. We're also supplying the mooring system, and we have a full ballast, external ballast spread on the barge, so that's a full ballast system and a full deballast system. For the loadout, we're supplying 8 SJ 850 strandjacks, each of them capable of pulling up to 900 tons. We have a breakout system, 4 1,000-ton jacks. The strandjacks are there for pulling this topside from the quayside onto the barge. And we have the breakout system that allows, during the breakout, to push the topside along and help the strandjacks in keeping the loads as low as possible on the strandjack system.
Currently, we're halfway through the loadout, and what you can see, the operational team are pumping the water out to provide buoyancy to the barge to enable a plane level loadout where the barge is in line with the quayside throughout the whole operation. Imagine it like being an orchestra. You have multiple instruments playing at the same time.
It really is it's like a seesaw, it's a balancing game. Not only are you counting for the load transfer of the topsides, but you're also working with or against the tide during this operation. It's very little tolerant allowed, so the ballasting system has to be very accurate.
With the Mammoet, you're always working with big size and heavy weights, but moving 30,000 tons, for reference, 30 million kilos, you never get used to it.
We always look back with pride because it's a lot of people that have left their families for multiple months to carry out a project as such.
Some of the team out here, they can be out here for months at a time, and to see the topside reach the end and a successful and safe job completion, it fills you up with pride every time.
Being here is one of the coolest aspects of my job. One day you're working on electronic equipment, the next day you're working on steel structure, and the next day you're in the field testing the system.
For me personally, it's always impressive to see such operations. The massive weights, the massive size, everything is big, everything is huge. It's unbelievable.
What sets us apart is the track record, I would say. Its portfolio of equipment, its personnel, and its expertise.
You know, we've been doing this for decades. You know, since the 80s, really.
It's a real one-team approach that grows over such a long period of time. And the beauty of that is re-engaging on future projects with the same teams that have grown together. And you no longer start from 0 or -1. You're starting at +2, +3. So you only need to listen to the client and open the Mammoet toolbox, because there's something in there that's ready to help the client provide a project on time.